Hi, and welcome to a lesson on linear programming. This is actually a paper 4 question from Cambridge IGCSE 0580 syllabus, and it starts off with some quite straightforward inequality questions. So the first 4 marks are hopefully really easy for you. So let's have a look at it. Pablo plants X lemon trees and Y orange trees. He plants at least 4 lemon trees. Write down an inequality in X to show this information. Now we need to just think about this quite carefully. He plants at least 4 lemon trees. So the least value, that number of lemon trees he's got is 4. Therefore it's 4 or more. So if we call the number of lemon trees X, X must be greater than or equal to 4. Okay, let's read it back. He plants at least 4 lemon trees. So the least value is 4 or greater. Okay, Pablo plants at least 9 orange trees. So same idea. Write an inequality in Y to show this information. Y is the number of orange trees. So the value of Y, if there's at least 9 of them, is greater than or equal to 9. Part 3, the third 1 mark that we can get here, is the greatest possible number of trees he can plant is 20. Write down an inequality in X and Y to show this information. Now he's only planting 2 types of tree, lemon trees and orange trees. So X plus Y, the total number of trees altogether, is the greatest possible number he can plant is 20. So it's anything up to 20. Okay, so this is going to be less than or equal to, as a maximum value, 20. Okay, so these are the first 3 marks of this question out of a possible 13 marks for this question in total. So it starts off pretty straightforward. I hope you agree. Okay, so that was part A done. Part B, lemon trees cost $5 each and orange trees cost $10 each. The maximum Pablo can spend is $170. Write down an inequality in X and Y and show that it simplifies to this. Okay, so an inequality involves obviously an inequality sign as opposed to an equal sign. And we know that we've got X lemon trees, each costing $5 each. So I guess 5 times the number of lemon trees will give you the total cost of those lemon trees, because each one is costing $5 if we do a sort of cost equation here. So for each lemon tree, we have $5. 1 lemon tree would be $5. 2 lemon trees would be $10. 3 lemon trees would be $15, and so on. Okay, we add that to the cost of the orange trees. Now they cost $10 each, so 10Y. Okay, and the maximum that Pablo can spend is $170. So the value of this is going to be anything up to $170. It's going to be less than or equal to, as a maximum value, 170. Okay, now write down an inequality and now show that it simplifies to this. So let's look at the link between these numbers. We've got 170, 34, we've got 10 and 2, we've got 5 and X. Hopefully you've noticed that if we just divide everything by 5, we are going to arrive at this answer and show that it simplifies to it. So 5x divided by 5 is x. 10y divided by 5 is 2y. We've got less than or equal to, and then 170 divided by 5, you can check, is 34. Okay. All right, so we've got the first 4 marks of this question. Okay, so far so good, I hope. The next part of this question is the real nitty-gritty, and it's where most of the marks are coming from. This next bit is actually worth 7 marks. Okay. So on the grid opposite, or below actually, draw 4 lines to show the 4 inequalities and shade the unwanted region. Now sometimes it's the wanted region, sometimes it's the unwanted region, in this case the unwanted. Now let's think about the 4 inequalities that we have. So let's write, I'm actually just going to write them down at the side. We've got x greater than or equal to 4. We also had y greater than or equal to 9, didn't we? We also had x plus y, let's tidy that up a bit, x plus y less than or equal to 20. And we've also got, the last one that we've got is x plus 2y is less than or equal to 34. Okay, so what the question is asking us to do now is to plot these inequalities. Now, they're all going to be solid lines because they are greater than or equal to or less than or equal to. If not, it would be dotted lines. So that's one thing I can look at straight away and know. And what I need to do now is to imagine, well, not imagine, I'm going to convert x greater than or equal to 4. I'm going to replace that, that inequality sign by equals. Okay, and I'm going to plot this one first. Okay, so x equals 4. It's going to be a solid line at x equals 4. So I go to the x-axis, go to 4, and I'm going to plot that solid line like so. All right, and then the next one, the second one that I've got is y greater than or equal to 9. Now what I'm going to do there is I'm going to plot, I'm going to ignore the inequality sign, and it's going to be y equals 9. Okay, we'll come back to it in a minute and we'll show why we're doing this. But for now, this is the process. So where would it be? It would be here. So through the y-axis at 9, straight across, horizontal. Now, this is where we get a little bit trickier because the next one that we're looking to do is x plus y equal to 20. All right, so again, I've just replaced this inequality sign by an equal sign. Now, what I would suggest you do in this case is the easiest thing, in my opinion, is to look for the y and x axis intercepts. And the way that we do that is we set them equal to 0. So if x were equal to 0, what would be the value of y that would make this equal to 20, or y would have to be 20? Right, and that's telling me then that one of the coordinates on this line is 0, 20. Okay, in fact, that is actually the y-intercept, isn't it? And if I set y equal to 0, do the opposite, okay, the x value would have to be 20. Okay, imagine that was 0 there, substitute 0 in, okay, because when y is equal to 0, looking at the x-axis, that is actually the other way of describing the x-axis is y equals 0, and the other way of describing this is x equals 0. Okay, so what we get is, this would be 20, 0. Okay, so now if I go and plot these two, I've got 0, 20, so along the corridor, up the stairs, 0, 20, would be here, and 20, 0 along the corridor to 20, 0. Okay, and then I'm going to go and put that in. Okay, so that is a line, actually, x plus y equals 20. In my opinion, I think that's quite nice and straightforward. So that's y plus y equals 20. All right, and then the last one we've got a similar idea. I'm going to approach it in the same way as number 4. So I've got x plus 2y equals 34. Okay, same idea. So I'm going to say if x were equal to 0, what would the y have to be? I think it would have to be 17. And if the y were equal to 0, what would the x have to be? It would have to be 34. Okay, so there, from that, I've got my x and y intercepts. When x is 0, y is 17, so that's the y-intercept, 0, 17. And I've also got 34, 0. Okay, so if I go and plot those things, 0, 17 is right here. And, oh no, it's not. What am I doing? 0, 17 along the corridor up the stairs, no, 17. And then 34, 0 would be there. Okay, so let's go and put that in now. So that is my line x plus 2y equals 34. Okay. Right, now that's actually, that's obviously quite tricky, isn't it? Okay, right, now then, I'm going to go back to my inequalities now, and it's a case of thinking about whereabouts I'm going to be shading, because it's asking me to shade the unwanted region. Okay, I'm actually just going to write on here what this one is. So that was x plus 2y equals 34. Yeah. Okay, so that's what that line was. Okay, so the next thing then is that I'm going to take my highlighter, actually, and I'm going to be shading out the unwanted region. Now, the wanted region is x greater than or equal to 4. This is the line equal to 4. Whereabouts would be greater than 4 then? Well, it would be to the right-hand side of this, wouldn't it? So I'm going to actually shade out the unwanted region as it's asking me to do. Whoops, I've gone over a bit there. Let's try that again. Steady hand. Okay, steady-ish. Okay, get the idea. All right, so there's that one. Okay, so I'm shading out the bit that's less than 4, okay? I only want greater than or equal to 4, so you can see hopefully why I've shaded out that bit, okay? Remembering that that was my line x equals 4. Let's actually label it too. Over here, I've got the line y equals 9, and I want the region that is greater than or equal to 9. So I'm going to shade out the part that is less than 9, right? So all of this is not wanted. Okay, so all of this can go as well. Okay, and I'll hopefully be left with a region that is wanted at the end of this. Okay, the next bit is I'm going to be looking at my next line that I drew, which is x plus y equals 20. Well, it's this one here. Okay, and I only want less than or equal to 20, or x plus y less than or equal to 20. Now, less than or equal to just means basically underneath the line. That's the bit that I want. I don't want over. If it was greater than, it would be above the line. If it's less than, it's below the line. So in this case, I want underneath this line, it's less than or equal to 20. Okay, so there's the line. I want below the line, so I'm going to shade above that line. Okay, so let's just get it right. It's above the line. So if I just sort of draw, just kind of draw along the sort of barrier area. There we go. That's the hardest bit probably, especially when you're doing it on using technology like this. Okay, yeah, like so. And then, yep, and then we just go and shade all of that out. Yep. Okay, so it's a big area gone. And we've only got a little bit of area left, actually, haven't we? So let's be really try and get this right. And then the last one is, let's do it in a nice orange, x plus 2y 34. So that's this line here, and it's less than or equal to, again, so it's below that line. There's only one tiny little bit, actually, that isn't already shaded, which is below that line. So I guess it's kind of x plus 2y is less than or equal to 34. Yeah, so it's only actually, it's this bit underneath that I want. So I need to shade, sorry, I'm just thinking, x plus 2y less than or equal to 34 is below this line, isn't it? So I want this stuff underneath here. I don't want the stuff that's above it. So I'm going to have to shade out that bit. Okay, so that bit's now gone above that line. Yeah, I want below the line because it's less than. So I need to shade out above that line. I hope that's made sense. Yeah, so above all that. So that's gone again. Okay, did actually just take out a tiny little triangle actually just there that was blank. So what I've got now is just this little bit. Okay, so maybe I could highlight it as well. Just show where that is. So, oh, no, I don't want to be doing that. Let's try this again. Yeah, I mean, I won't go over it too much. I don't want to overcomplicate it, but it's this sort of almost a triangle shape. Okay, so it's it's a quadrilateral there. And we sort of the top part of the triangle chopped off because of the last bit of inequality shading that I did. So it's this bit here. Okay. Right, okay, so we've done that, and usually, I know, well, not usually, but sometimes they'll ask you to label it, say R, something like that, okay? So there's our little bit. On the grid opposite, draw 4 lines, show the 4 inequality, shade the unwanted region. Now I've got my 7 marks in the bag, I did it correctly, okay? So I've got my region that is unshaded. And then the next part says, calculate the smallest cost when Pablo buys a total of 20 trees. Now this part, to be honest, is quite specific. It's when he buys a total of 20 trees. And there was a part of the question that was quite specific about a total of 20 trees, okay, which was this bit here. Was it? No, it wasn't. It was this bit here. So there was a particular line that was drawn where the greatest possible number of trees he can plant is 20. All right. Beyond that, we can have less or we can have more. So really, the point that I'm looking at here needs to be on this line here. And, with all the shading that's gone on, it's hard to see it now. But this was the line x plus y equals 20, just here. Okay, so see that pink line there that was drawn? Okay, so it's quite important to get this right. Calculate the smallest cost when Pablo buys a total of 20 trees. Now, it needs to be in this region, but it also needs to be on this line to satisfy a total of 20 trees. Okay, that is the line. And we need to minimize it. Okay, so what we need to do is to look for vertices. This is the key here. Okay, vertices are corners. Now, there's a corner and there's a corner of my shape. There are two other corners of my shape that could possibly minimize, but they're not lying on this line. So they're not specifically saying that the number of lemon trees and the number of orange trees equals 20. This line are all the possible solutions where the number of lemon trees and orange trees is equal to 20. Okay, over here, it's not quite the case. For instance, here we've got 4 plus 9, that makes 13. There's 13 trees here. Over here, we've got 9 plus, no we haven't, we've got 11 plus 9, that makes 20. And here we've got 6 plus 14, okay? So the two possible values that we can have is that we could either have, there are two possible vertices, we have 11, 9, and we have 6, 14. Now, one of those, okay, there isn't another solution that's in this region or on the boundary of this region that also lies on this line. Okay, so we need to analyze which one is going to create the smallest cost by using the cost equation. And we know that the cost of a lemon tree was 5, if I remember correctly. Yeah, and the orange tree was 10. So which one of these is going to give us the smallest cost? Do you know what I'm going to do, actually? Is that I'm going to take a screenshot and go on the next page because I'm running out of room here. Okay, so there we go. So there's my screenshot. Let's go on to the next page. Okay, there are two possible numbers of trees. Okay, you might already have spotted which one it would be. We could either have 11 lemon trees and 9 orange trees, or we can have 6 lemon trees and 14. Oh, sorry. Why it's 14. Now, what would the cost be in each case? Cost of a lemon tree, we know familiar is $5, and an orange tree is $10. That's correct, right? I'm going to double check that. Yes, okay. So going back, okay, in this way, the cost here would be 11 lots of 5 plus 9 lots of 10. And the cost here would be 6 lots of 5 plus 14 lots of 10. Okay, which one is going to give the smallest cost? The cost here would be 55 plus 90, which is $145. And the cost here would be 30 plus 140, which would give us $170. Okay, so it would be this one. So the answer here would be 145. It's asking us to calculate the smallest possible cost when Pablo buys a total of 20 trees. Okay, so that was going a bit further. That was a couple more marks, if I can remember correctly. So yeah, altogether there were 13 marks for that paper 4 question. I really hope that that's been helpful. If you've enjoyed my video, please like and subscribe and leave me a comment. I really hope it's helped you with this topic. It is a challenging one. Obviously, it started really easy. It went quite far in there. You just have to be really careful. This can be quite fiddly. Just take care. And then sometimes you get the odd question. Always usually always usually, bit of a contradiction there, but usually related to vertices. Okay, so read the question very carefully. It was quite specific there about which line it wanted them to lie on. Okay, all right, good luck with your work.